In today's modern world of technology, autonomous aircraft or drones have become one of the most advanced technological tools. But the question arises, how can these devices fly accurately and stably in the sky? The answer to these questions lies in part in advanced sensor inside these devices. Today, we intend to take a look with you at one of the most important of the sensors, the gyroscope, and see how it works and why it plays a vital role in autonomous aircraft. In this video, we only introduce the gyroscope and its applications in autonomous aviation, and we will not go into the detail of its operating principles. Mechanical gyroscopes are named and recognized based on the principle discovered in the 19th century by Jean-Bernard Foucault, a French physicist who gave the name gyroscope to the wheel or rotor installed in gimbal rings. The angular momentum of the rotating rotor caused it to maintain its state even when the gimbal assembly was tilted. In the 1815s, Foucault conducted an experiment using such a rotor and showed that the spinning wheels maintains its original directions in space regardless of the Earth's rotation. This capability suggested numerous applications for the gyroscope as a direction indicator. And in 1908, the first workable gyroscope was developed by the German inventor H. Anschutz Kampfi for use in ships. In 1909, the American inventor Elmer S. Spray built the first autopilot using a gyroscope to keep the aircraft on course. The first ship autopilots were installed on a Danish passenger ship by a German company in 1916. And the same year, the gyroscope was used in the design of the first artificial horizons for aircraft. The gyroscope is essentially a rotor fixed in the retaining ring called gimbals. The gimbals have frictionless bearing that isolate the central rotor from external torques. The direction of rotating is determined by the axis of rotation. The rotor rotates in one direction and has 3 degrees of rotational freedom. Once fully balanced at high speed, the axis of rotation maintains its highest speed central rotor. Now, when external torques or rotations around a specific axis are applied to the gyroscope, the direction can be measured using the phenomenon of precession and path deviation. This precession refers to a change in the direction of rotational axis of a rotating body. In other words, when an external torque is applied to an object rotating about an axis, precession occurs along the direction perpendicular to the axis of rotation. This rotation around the specified axis of rotation and information about the rotation is transmitted to a motor or other device that applies torque in the opposite direction, thereby cancelling the precessional movement and maintaining the direction. It is also possible to prevent precession by using 2 gyroscopes placed perpendicular to each other. The rate of rotation can be measured by oscillating the reciprocal torque at fixed time intervals. Therefore, a gyroscope is a sensing device designed to measure the rate of rotation and determine orientation in space. Its working principles are based on the laws of mechanical motion. In a traditional gyroscope, a small wing spins rapidly, and due to the angular momentum resistance against changes in its rotational direction is created. This property allows the gyroscope to maintain its orientation in space. In autonomous aircraft, a type of advanced gyroscope called a MEMS gyroscope is used. Instead of using a physical wheels, this type of gyroscope uses microscopic structure and mechanical electrical effects to measure rotation. MEMS gyroscopes have high accuracy and can be easily used in small and lightweight devices. In autonomous aircraft, the gyroscope plays a vital role. The sensor enables the aircraft to measure its rate of rotation in 3 different axes: pitch, movement up or down in the forward and backward direction; roll, rotation around the longitudinal axis of the aircraft; yaw, rotation around the vertical axis, or change of direction. Using this information, the aircraft control system can determine its precise position in space and, if necessary, apply the necessary corrections. For example, if the aircraft is tilted in one direction due to the strong wind, the gyroscope detects this change and the control system adjusts the engines or wings to retain the aircraft to its original positions. Also, the gyroscope plays an important role in stabilizing the aircraft. In unmanned aircraft, which must fly independently, the gyroscope provides the control system with accurate information about the aircraft's motion status, so that the system can control the aircraft's path, altitude, and speed. Gyroscopes are widely used in autonomous aircraft in various applications. 1. Aircraft stabilization. The gyroscope allows the aircraft to be stable against oscillation and the effects of wind. 2. Autonomous flight control. In unmanned aircraft, the gyroscope provides the flight control system with accurate information about the aircraft's motion status. 3. Navigation and route planning. The gyroscope is used in navigation system along with other sensors such as GPS and IMU. If GPS is not available, the gyroscope can serve as the primary source for determining the orientation and position of the aircraft. 4. Camera stabilization. In aircraft used for filming or photography, the gyroscope helps stabilize the camera to obtain stable and non-oscillating images. In this way, the gyroscope is one of the most important sensors in autonomous aircraft, allowing the aircraft to determine its position in space and enabling stable and precise flight control. Without this sensor, the accurate and safe operation of autonomous aircraft would be impossible. If you enjoyed this video, please like it and share your comment with us in the comments section. Also, if you want to know more about technology related to autonomous aircraft, follow our channel. Until later, with your support, we hope to provide you with the best experience in this field.